Hello, everyone, and welcome to the first episode of WDTD's new webinar series, Research to Operations, Operations to Research Tales, Roots. I am Elisa Bates of WDTD and OU CIWRO. In partnership with NSSL, this new webinar series will go beyond Tales from the Testbed to highlight experimental tools and techniques that are already being used in warning operations. Today's webinar will feature several forecasters from the NWS Southern Region and an emergency management partner. First, they will discuss their utilization of the Warn-On Forecast System, WoFS, for warning operations and IDSS during the June 23 severe weather event in the Southern Plains. And then we will hear from the WoFS developers, who will give a recap of 2023 and a sneak peek of what's in store for 2024. Since we have forecasters from several WFOs represented today, they will be presenting in roughly a west to east chronological order. First up, we will hear from Luigi Macariello from WFO AMA, then Todd Lindley from WFO OUN, and their EM partner David Hogg from OU CIWRO NSSL, followed by Ted Ryan from WFO FWD, and then we will finish up with Brad Bryant, the MIC at WFO SHB. The WoFS team members presenting with us today are Patrick Burke from NSSL and Pat Skinner from OU CIWRO NSSL. As this is our first Roots webinar, let me take a moment to list the objectives of this new series. As I mentioned, this series will expand beyond the HWT to highlight experimental tools and techniques that are already being used by the field. We will highlight IDSS applications and potential best practices for these new products. Our hope is that this webinar series will improve communication and collaboration amongst operational personnel, researchers, and instructors. And as regional science sharing webinars are popular, we hope to help the O2R process by bringing these cool new regional tools or applications to the national scale. Do note, though, that although these tools are being used in operations, they are still experimental and they still must go through NWS's approval process before they become operationally supported. With that, I will now turn things over to WoFS Program Lead Patrick Burke to kick us off with a brief overview of WoFS before we then dive into the events of June 15th.
Awesome. Thank you, Elisa. Great introduction. This June 15th event was really special. For several years we've been documenting, and forecasters have been helping us document successes with the Warn-On Forecast System for individual storms and individual events. But this was a day where we really saw sort of the fruition of all those years of kind of outreach and forecasters getting practice, and you had several offices across the Southern Plains who were comfortable in using the output for their real-time product generation and decision making. You had emergency manager partners doing the same, and so we thought this was really a nice story worth telling of an event that progressed through several different offices who were using the Warn-On Forecast System. So I'll just give a brief recap here to make sure we're on the same page. Hopefully this slide is review for many of you. But WoFS is a rapidly updating storm scale ensemble that makes probabilistic predictions of individual thunderstorms. You can think of this as the first NWP system that's been really designed with watch to warning operations in mind. So the idea is to create hyper-accurate analyses of individual storms and then project them forward. And of course, there's so much uncertainty at the city and county level in thunderstorm prediction that we then want to rerun that ensemble every 30 minutes to keep pace with that uncertainty as we get new observations in. So that's the design, and because of the computing power that requires, it runs on a limited domain about the size of the four corner states so that we can move around to different severe weather events. And so it's not available every day all the time. It is still experimental, but it's certainly moving towards operations. And one of the other key characteristics is that we don't have a control member. We really try to emphasize probabilistic predictions, so you see a lot of percentile and probability fields. We work closely with National Weather Service forecasters over the years to design efficient ways to visualize all of this data, all this model output, such as the loop on the left you're watching there is a probability field for 2 inches of rainfall, and then you have the individual thunderstorms from the 18 different forecast members in the black shaded spots. So pretty unique system, and I'm looking forward to hearing our WFO partners talk about it. I did provide a link there in the lower left of this slide to a training webinar that Pat Skinner and I delivered through WDTD earlier this spring, if anyone has not caught that yet. So with that, I'll turn it over to Luigi out at Amarillo. Thanks.
Hello everybody, my name is Luigi Micrello. I'm the one of the lead forecaster here in Amarillo. So we're going to focus on more the tornado genesis that with the development of the eventual EF3 tornado that hit Perryton, Texas that afternoon. So on your image you see in front of you, you can see that the SVC horizontal velocity, vorticity, and outflow trough axis on the SVC analysis on the bottom image. You can see that was indicated very well of the different surface analysis that was conducted to better analyze what WoFS was giving us as the storm progressed. And then on the image you can see on the right, it is the 25 flash probability on the ensemble using WoFS in the 5-minute period. And you can see as co-located with the radar image on the top with the states indicated for Kansas, Oklahoma, and Texas, since we're focusing on the northeast panhandles into southwest Kansas. You can see the lightning flash intensity was well documented as the storms developed further along the dry line that started about near Liberal, Kansas, and developed south going into the northeast panhandles, where we were expecting storm developments to continue into the afternoon hours. And you can see in the last kind of image on the loop for the storm developing Perryton now, the onset of what was going to be a very impactful day for that area of the northeast Texas panhandle. We see, so in particular now we're going to focus in on the two images on the left. That's the top will be your WoFS probability of a 30-minute probability of seeing a tornado. And you can see as we go throughout the day, given those parameters shown on the SVC mesoanalysis, the conditions were extremely favorable as we go into the afternoon hours, extending the line of storms along the dry line into the Texas panhandle. But contrast to the SVC mesoanalysis page at the time, the major improvement for WoFS was the temporal and spatial resolution that it provided. So you can see there's actually a little bit of a lull in the activity for the SRH component of the mesoanalysis page, which the WoFS is able to fill in and give us that higher confidence on the forecast side of the desk that we were anticipating a supercell develop with favorable parameters to see a tornado. And around 2206Z, that Perryton tornado did touch down within that 40% probability of the tornado, as you can see on the image of the radar on the right, where the storm developed into a supercell rather quickly with that dry line following closely behind it, with all the observations showing that potential for the tornado was definitely there, and it definitely did as it was forecasted to do. So again, using the combination of local observations, SVC analysis, and the WoFS, and also other remote sensing tools at our disposal. So the message for the public for IDSS, this is one of the more important things we feature. So we divided our CWRO into two different sections for the most likely area of severe weather based on the higher preps between the 4 to 7 p.m. time frame, and then even additional thunderstorms development with severe capabilities working southeast into the southeast part of the Texas panhandle. So as that probability of lightning further developed leading south along the dry line, that gave us the confidence to better message to the public and our partners what those threats were coming, especially going later into the afternoon hours, where the tornado threat did drop a little bit as we went into the evening hours, of course, with the daytime heating component. But again, to show that additional development was also possible in the southeast Texas panhandle. So going forward, as we go into future severe weather seasons, we're going to adopt a new concept for our mesoscale analysis desk person as we're leading the next charge into the next severe weather event season. And then using the monochromatic color scale, as you see on the main screen in front of you, is best identified, especially with the color coordination of the NWS, with correlated with red for tornado, yellow for severe, and et cetera. Just a very focus on the impacts that's in ongoing or about to develop. So this image you see in the middle is kind of an example we would use between, for example, if a watch were to develop, a watch were to be issued, and then before a warning. So you can see that there's a 30-40% chance of a storm moving towards Perryton with the potential for tornadoes given by the WoFS probability and other factors that we look at. So this would be a great image and great tool going forward to get really involved alongside of that radar operator to make sure that our partners and our public are aware of the latest changes going on. And also with the new chat service we have now, we can share these images right to them, and it'll be very beneficial for our partners to make those decisions as these storms headed their way. So we definitely look forward here in Amarillo to use this further and to further develop and expand our IDSS capabilities. And with that, I will pass along to my counterparts in Norman, Oklahoma.
Thank you, Luigi. Well, while Luigi and the crew out at AMA were dealing with the development of the severe weather episode out on the high plains of the Texas Panhandle, we also had two discrete supercells that developed in southwestern Oklahoma, largely between about 2:30 and 3 p.m. And by about 3:12, we had a severe thunderstorm warning in place out to the west of Lawton, Oklahoma. And when our forecasters were starting to pick up on this signal from the 1930 Z run of WoFS that actually showed a very strong signal for localized damaging winds associated in the general vicinity of those supercells. You can see here the 90th percentile 10-meter gust from WoFS at the 1930 Z run was indicating a max wind gust upwards of 88 knots, very near Lawton, Oklahoma. So in our mesoscale messaging via NWS chat and social media graphics, we started to really talk about the potential downstream impacts of these storms, including specific mention of the warn-on forecast system showing maintained UH tracks that eventually turned right and threatened the areas downstream from roughly Anadarko to Lawton. That was issued in NWS chat around 3:24 p.m. followed 3 minutes later by the accompanying mesoscale graphic that highlighted the area around Lawton and downstream of these storms with a severe weather threat increasing, specifically talking about the damaging wind gust potential. About half an hour later at 4:01, confidence continued to increase for this scenario, and it was posted in chat that WoFS continues to suggest that these storms will turn toward the right, east to southeast over the next few hours, and this will increase the risk in and around Lawton, and that specifically we are watching strong WoFS signals of intense damaging winds and emphasizing the point that there is a strong signal for potentially intense damaging winds in the vicinity of Lawton. And that messaging was issued at 4:01 p.m., followed again by a destructive severe threat increasing graphic at 4:40, highlighting the area near Lawton downstream towards Duncan. Eventually, at 4:42 p.m., a 103 mile per hour gust was measured in Lawton with some structural damage and damage around the community there. So in general, that's about a 75-minute advance notice or effective lead time for the damaging wind gust potential around Lawton prior to that 103 mile per hour gusts. As the event continued to unfold by early evening, the complex of severe convection that Luigi discussed out over the Texas Panhandle began to move east and impact western Oklahoma, and additional supercells developed again in southwest Oklahoma and central Oklahoma. And again, we were able to use output from WoFS to really identify localized corridors within the kind of the watch to warning paradigm that were at enhanced threat of very large hail, and again indicated some tornado risk as well. And with that, I'll pass it over to one of our emergency management partners, David Hogg.
Hi everyone, my name is David Hogg. I'm a research associate here at the Cooperative Institute and NSSL in Norman. But for the purposes of this talk, probably more relevantly, I'm also a volunteer with McLean County Emergency Management. With my role there, I sort of try to embed myself in their weather operations, both before and during severe weather. McLean County is the county just south there of the Oklahoma City metro area, just south of Norman. And so as part of working with McLean County, I try to provide both, forecast information, but then real-time weather support for them. And it's been a busy year already. It had already been a busy year in 2023. We'd had a significant tornado event in April. We had an EF3 tornado. And then we had a second, significant tornado day with a few more homes damaged in May. So there was a fair amount of trepidation and a little bit of just being worn out going into this event. So on the screen there, you can see some of the slide deck that I tend to send to them before severe weather events occur. And that's both for the county folks and then all the jurisdictions within McLean County as well. So they're receiving this just to kind of bolster their knowledge. They get all the same things from the Weather Service as well, but it's an opportunity for them to have someone that they can talk to directly and someone that lives in their community and just works with them. And so with this event, the thing that we were really concerned about and really the question that we had was about timing of thunderstorms. We knew that there was a really high probability that we were going to have severe weather, including most likely damaging wind gusts at some point, but it was really the question of, do we get one round or two? And it was that early round of thunderstorms where we had a lot of questions and a little bit of concern. We knew that the later in the evening storms were more likely to happen. So as we switch slides here, you see how that timing graphic from the Weather Service changed to say, earliest start time there is now. As Todd was showing just a minute ago, that first really large supercell that formed in southwest Oklahoma there in Greer and Kiowa County, that storm, its initial movement looked like it would move right down Highway 9 into McLean County. That's where our storms tend to come from. That's where the people that work there in emergency management, that's where they know where to look for storms. And so as that storm was forming, by being able to access WoFS, by being able to sprinkle in some of the WoFS information to my partners there in the emergency management office over the last few months, they'd kind of gotten used to understanding a little bit of what WoFS can do, what WoFS can show. And so between what I was seeing and then between what Todd and the Weather Service there in Norman were putting into chat, it became clear pretty early that storm, even though we would have expected it to come into McLean County, was going to take that hard right, was going to take that hard southeasterly turn and move, more into Comanche County and Stevens County. And so while it may seem like kind of a small thing, being able to tell them and give them that heads up to say, hey, this storm is not going to impact you. We're going to have more storms later. We knew we would have more storms later. But to be able to tell them that and give them 3, 4, even 5 hours where they weren't standing up in EOC, they weren't having to staff, they weren't sending people out, that was really valuable. And you can see some of the feedback there from some of the different emergency managers across the county that I work with. And so this was definitely an impactful case for them just to understand how WoFS can provide that heads up, not necessarily to say that, yes, we are going to have a storm, but in this case, it was really a heads up to say, hey, we don't have to worry about this one right now. And I think especially in more rural areas or more lower resourced jurisdictions, that's a really important thing for the Weather Service and for us to be able to communicate to our emergency management partners. So with that, I will pass things off to our colleagues from Fort Worth.
Okay, thank you. So as this thunderstorm cluster that was in southwest Oklahoma continued to move southeast, it scraped across the northern and eastern parts of our CWA. This ended up being a high-end hail event for us that actually produced the CWA record, 5.9-inch diameter hailstone, which is just a half-inch shy of the state record. So certainly that was pretty remarkable. So let's go to the next slide and look at some of the mesoscale parameters here that we were looking at. Again, down in Fort Worth, we had the luxury, I guess, of watching storms initiate in someone else's CWA and following them into our area. So that gave us a lot of time to analyze the WoFS output. What we saw on this day is a very volatile environment with mixed layer CAPE over 5,000 joules per kilogram, and a stalled front kind of laying right along the southwest Oklahoma where those thunderstorms started to develop through our northeast CWA, and northwesterly flow aloft that was actually quite strong for this time of year. All of that kind of gave us a conceptual model that what was going to form up in southwest Oklahoma would probably track southeast into our area and could become a Boeing segment or at least a formidable cluster of thunderstorms. The other thing we were watching was a dry line out to the west. We were also concerned about whether we were going to have initiation along the dry line. And so as a result, a tornado watch was issued for most of our CWA. So on the next slide, I'll show you some of the WoFS output. Here we used the 2 to 5 kilometer updraft helicity product to show us a general proxy for severe weather potential. And right away, you'll notice what stands out is that very strong signal with that southwestern Oklahoma cluster of storms moving rapidly south eastward into our CWA. And the other thing that stands out is that dry line. We were just having trouble getting convection sustained on that dry line, and the WoFS showed just kind of very low confidence output that perhaps maybe something might develop there, but really no signal there. Some of the machine learning guidance that we used for this event, I have the probability for severe hail and severe wind showing 60 and 75% calibrated probabilities for severe weather with those features. And using those calibrated probabilities really helped us kind of get some ground truth confidence to really verify that that conceptual model of what we expect and what the WoFS is showing is aligning, and with those high probabilities from the machine learning, we could actually do something like create some graphics that you'll see on the next slide. So we produced 3 of these kind of watch to warning graphics, basically highlighting the area that was expected to be high confidence affected as the WoFS had forecast and matched our conceptual model. We even threw in some timing estimates there of when those features would arrive at certain communities based on the WoFS output. Some of the be prepared for, we mentioned very large hail greater than 2 inches, damaging winds greater than 75, and a medium chance of tornadoes. We did not have any tornadoes in our area. With this event, we did issue a couple of tornado warnings though. And we had actions. So we were telling people some specific actions that they could take. So you may remember I mentioned that we had this tornado watch for most of the area. Again, that convection on the dry line failed to materialize. But it's very difficult for forecasters to cancel a tornado watch early, especially if the dry line's kind of hanging out there still. But it's very easy for forecasters to kind of focus the messaging where we think the actual threat is, and the WoFS really helped us do that. So on the next slide, you'll see some of the feedback that we got from posting these graphics. We put them in NWS chat. We used the WoFS output to answer some questions. There were some outdoor graduations ongoing in the area that evening, and just a lot of questions from emergency managers. You'll see that each time we did a graphic, we put that in the chat, and we got lots of positive comments from emergency managers and media alike from producing that type of output based pretty much solely on the WoFS. So on the next slide, I'll offer some summary thoughts. The WoFS really gave our forecasters a critical confidence boost when that output was really kind of matching the conceptual model of what they think is going to happen. Again, it's hard to cancel tornado watches or areas of tornado watches early, but it's easy to shift the messaging focus on the area of greater concern. And as far as the WoFS performance as a whole in this event, generally pretty good, but storms did take a little longer to organize. It was a bit fast in moving them down to the southeast, which did impact the timing. So we put the timing on the graphic, and it ended up being 30 minutes to an hour and a half later in reality than what actually occurred. Because of this kind of timing issue that we were having, we actually had a 4th graphic that we had put together, but we didn't disseminate it, just kind of watching and waiting to see how things went. So with that cluster storm did eventually move into Shreveport's area. We wish we had issued that 4th graphic in hindsight, but for more on the impacts in Shreveport's area, I'll pass it over to Brad.
Hi, everybody. This is Brad Bryant at the Shreveport office. We're the office directly east of Fort Worth, and it was interesting on this day. The SPC risk was really focused across Oklahoma and Texas, and it took kind of really late in the day to the risk to start to ramp up downstream going through our area, as it looked a little more likely that troublesome convection would organize and move in to our Shreveport forecast area. So I just wanted to quickly talk about the days leading up to this event. Ted laid out the synoptic situation with a stalled front and extreme instability and high wind shear. And we were dealing with this pattern, a stagnant pattern of anomalously fast and perturbed flow aloft, juxtaposed with very high instability along this stalled front. And on the 13th, 2 days before, it produced a bunch of supercells that produced some really big hail and sig wind and sig hail across our area. And then the next day, on the 14th, we got kind of a really big hybrid supercell thing. That's the radar image on the bottom. That moved just south of Texarkana, produced a EF2 tornado, and estimated wind gusts up to 100 miles an hour from a storm survey. But both of these days, the mode was primarily supercellular. So we had some questions about, on the 15th, would the mode be the same? All right, so one of the reasons that Storm Prediction Center risk for our area wasn't very high on the 15th is because the convective allowing models, you can see on the top, this is guidance from the 12Z run on the 15th of the HREF. There was showing potential, this is maximum wind gusts from all the members, and there was definitely potential for some windy storms in our area, but there wasn't really any specific consensus on timing and location from these 12Z HREF runs. The HRRR was the most consistent in predicting a small thunderstorm complex, potentially a derecho maybe, passing through the CWA during the night. And that model had been doing pretty well in this pattern, so we were very worried about this happening. And we used the WoFS output on the evening of the 15th to increase confidence of an upscale growth of supercells and small clusters to our west and northwest, merging into a larger, more organized thunderstorm cluster that would race into our area. This WoFS animation shows output from the 3Z run, showing a reasonable worst case scenario of 55 to 75 mile an hour gusts coming into our east later on that evening and into the overnight hours. So that definitely increased confidence that we might be dealing with a derecho class thunderstorm cluster. So this slide's got a lot going on it. I probably should have separated it into two slides. One of the interesting things for me was on the right, there's kind of cascading tiles of the 0Z run, looking at the composite reflectivity greater than 40 dBz, and then the 1Z run in the middle and the 2Z run on the bottom. And the theme there is, if you look at the WoFS output, the archive, you can do neat things like overlaying reports and warnings in regard to where these signals were. And you can see that the 0Z run was showing potential for a cluster that in actuality was kind of a lot slower than what it's depicting. And that's still the case with the 1Z and 2Z runs, but it's getting better with time. So we did have enough confidence of a developing derecho type cluster, and it spurred this graphic, this watch the warning graphic that we issued. One of the problems that we were dealing with, if you can see the small animation on the top right, and it may not show up too well, but there was a supercell just west of our area that Fort Worth was dealing with. It was producing all kind of severe weather, and it was deviating right very hard, and the upscale growth was delayed in happening from what the WoFS was showing. And we almost pulled the trigger on this graphic maybe an hour or two before we actually issued it, but we kept waiting for that upscale growth. But once it happened, just kind of right on the border of our CWA, our west, and Fort Worth's east, that cluster really very rapidly accelerated to 50, 60 miles per hour and produced widespread wind damage through the middle of our CWA. On the bottom left reports graphic shows just a lot of wind reports starting in East Texas, moving through northern Louisiana, through central Mississippi, even in Alabama, some 500-mile long path of damaging wind reports. And we did have some significant wind reports, quite a few from Shreveport west through East Texas, quite a few 80-plus mile an hour wind reports and survey estimates. One of the things that I mentioned was the WoFS was initially too fast. Patrick in NSSL said that sometimes that's a bias you can see with the WoFS as it predicts upscale growth of convection maybe a little too soon at times. And we saw that, and we kind of reacted to it and delayed issuing some graphics based on what we were seeing. But the WoFS really did give us a lot more confidence that we'd be dealing with a big-time thunderstorm cluster coming through overnight. One of the things I was kind of concerned about was in this WoFS domain, the Shreveport CWA, the kind of western, northwestern part of the CWA is on the edge of the domain. and whether that could have compromised the integrity of what it was predicting coming into RCWA. But apparently that's not the case. I mean, that's actually not a bad spot to be in, because everything organizing in the domain has a long time to, I don't know, correct itself before it gets into our area. So yeah, this was a very impactful couple of days. It was probably one of the worst thunderstorm clusters coming through in June in RCWA in many, many years. And the WoFS helped us get the public ready for that coming. Thank you.
Thank you all very much. We will now transition into a 5 to 10 minute Q&A period for our WFO and EM presenters before we go into the WoFS developers, who will tell us about a recap of 2023 and what's new for 2024 with WoFS. I will start us off with the question. So this is for all of our panelists. So we've heard from different WFOs and how you used WoFS in different ways and experienced unique circumstances while using WoFS for the same event. Among our presenters, could we please have a short discussion on about how you all think WoFS could be used during warning operations in general, and kind of tying this event together?
Yeah, all right. I guess I will kick things off. For us in Amarillo, like especially being that we were in the beginning of this event, trying to see where the storms were developing in the first place, for operations, especially along driveline where we have those conditions set and ready to go, we're just watching the storms develop. The WoFS probability was instrumental, especially filling in the gaps for where other data sets, when I mentioned before, the temporal and spatial resolution of other data sets may have not quite grasped some of the areas of concern that we're looking at. And especially parts of our CWA in particular, in the Northeast Texas Panhandle, we're about equidistant between the Amarillo radar and the Dodge City radar. And that part of the CWA, you definitely need to look at other different data sets to look at what's going on in the area. So having WoFS as more of a concentrated area and having it constantly update for us during operations was quite vital in terms of operations and unfortunately for a tornado that did some damage to a town. So going forward, I definitely look forward for the future developments that we'll hear about how we can use this going forward for sure.
Yeah, this is Todd and Norman. I'll follow up on that. And having experience using WoFS and coordinating with the WoFS development team over at NSSL dating back to 2017 or so, I can really summarize the most effective and beneficial use of WoFS in a WFO is to increase effective lead time. I think it's a very unique system that allows you to take current observations and project them forward, really filling a gap in that 0 to 3 to 4 or 5 hour time frame where there traditionally has been a silent period in our forecast and warning products. But it's a unique system that really bridges the gap between observations and the traditional convective allowing models, or NWP.
Yeah, this is Ted in Fort Worth. I don't want to repeat what Todd and Luigi said, so I'll just add that I think one of the biggest advantages for WoFS is as a mesoanalysis tool. I didn't show any of the mesoanalysis fields, but being able to see how the CAPE and instability and shear are evolving over the next few hours, how that's going to potentially impact the storm mode and the development is really critical. I think that there's some veteran forecasters that can do that kind of mesoanalysis on their own and in their head because they've seen it for so many years. What I really love about the WoFS, though, is that younger forecasters that may have an inkling of how they think things are going to evolve, but don't have the confidence yet to tell emergency managers or partners or create a graphic based on their inkling, can look at the WoFS and see that it shows the same thing that they're thinking, and then they suddenly have this really boost of confidence to go out and actually do some of this stuff. So I think that's one of the great benefits of WoFS.
This is Brad in Shreveport. I don't know if I have much to add to what everyone else has said. Having the capability of this output unlocks this potential for the watch the warning graphic, which is going to be an increasingly great tool going forward. One of the things about the WoFS is that there's a lot of output that you can view and a lot of data and just getting used to it and figuring out what's most useful is good ahead of time before you really need it, because just going through and looking at reflectivity from individual members isn't terribly helpful and just offer more confusion. But a lot of the machine learning output and a lot of the percentile and probability data using all the members, that's the real weight and utility seems to come in. Thank you.
So we've heard from all of our WFO participants and their perspectives on using WoFS. So now I'll direct a question to David from your EM perspective and in general. So how familiar do you think EMs are with WoFS and how do they use it?
As a general rule, I would say there's not a lot of awareness of WoFS in detail. I think there's a general awareness and a recognition that, just like has been stated, that there is so much more information that's coming out now in that watch to warning time frame, or like Todd mentioned, that increased lead time or projecting out into the next few hours. I think emergency managers are seeing that. They're expecting more information than what they used to have available. So I think that's a very positive thing. In terms of their actual understanding of WoFS as something that is revolutionary or new, a real awareness. Now, I will say that Patrick Burke and I have had a few opportunities in the past year to go to emergency managers, both conferences and workshops, and do some education on what WoFS is and get some feedback from emergency managers, but from your perspectives, showing them here's some of the capabilities, here's some of the ways that WoFS are being used. What is valuable? What works for you? What information do you need? And I think one of the big things from an emergency management standpoint is just that narrowing down of timing, of course, but also of geography, of really being able to focus in on areas at greatest risk and maybe areas at a slightly lower risk. Emergency management, typically, you're talking about someone that may have a jurisdiction that's a county size, or even in a lot of cases, just a city or town or some other entity. And so the geographic footprint for an individual emergency manager is so incredibly small for what they're really concerned about. And so having a tool that can really focus in that and sort of narrow that window down a little bit, I think provides a tremendous amount of value on top of that timing piece as well.
That's great insights. Thank you so much, David, for that. It's really great to hear that the EMs are enjoying this new product as much as the NWS forecasters are. We really want to make sure that we develop the right products for our partners and end users. We are now going to go back to Patrick Burke, who will give us a brief review of WoFS events in 2023 and our tool update and a peek at what's in store for 2024.
All right. Thank you, Lisa. Thanks, everyone, for hanging in there. It's been a great presentation, and I just wanted to briefly, recap what we did this year. We ran in real time for 43 different days in 2023, and that's right around average. We usually land somewhere between 40 and 50 runs a year of these experimental runs. The one thing that was pretty unique this year was we demonstrated the ability to run two different domains at the same time. On the left-hand graphic there, you're looking at the March 31st tornado outbreak. We were able to capture nearly all of the tornadoes that occurred. And similarly, we ran two domains when Tropical Storm Hillary came into Southern California back in August. So that has been a new development, something that we're proud to be testing in our cloud-based system. We also performed a lot of outreach this year. And it really is, since about 2022, we've seen this explosion of interest in WoFS. Word got out, not just in our local neighborhood here in the Southern Plains, but we've seen interest from all regions of the Weather Service. So we've been invited to speak as WFOs have their spring, convective tune-up kind of workshops. We'll give a little presentation about warrant forecast system, a lot of outreach through conferences, and like David mentioned, to the emergency manager groups this year. We've begun engaging with them. We also hope to do more with broadcast meteorologists in the future as well. We've got some research we're trying to get funded for that. There's another aspect of the WoFS story here concerning the FV3 dynamic core that I did want to give a nod to, because there's been a lot of work that has taken place behind the scenes here at NSSL for about the past 3 years, really. And this is one of those things that the warrant forecast system matured right about the same time that modeling in NOAA became very different with this move to unify all the systems underneath the unified forecast system and to use this single dynamic core, the FV3. After 3 years of experimentation, we were able to document, our scientists here, all the reasons why the FV3 simply does not work for the WoFS style of modeling on the convective scale using rapid data assimilation on a limited size domain. Those reasons were communicated out through conferences this summer, and we're working hard to get some things published. This obviously has some implication for NOAA modeling in general. So it's kind of the foundation of our science and modeling, some contributions there from the NSSL group. But in the meantime, because FV3 does not work for WoFS, we're now exploring another dynamic core called the impasse model, and it's shown to be a lot more promising for a potential next generation version of our model. Now, taking a look in the near future, we're still in this experimental mode, but we do have some exciting new things coming along. So the Storm Prediction Center has contributed some money to our cloud-based system to run for at least 20 additional runs above and beyond what we typically do. We actually have been talking about them this fall about beginning this experiment over the cool season. So we'd like to sample more cool season severe weather events, not necessarily things that would have to be, enhanced and moderate risk like we normally do in the off season, so to speak, but maybe get some slight risks in there, try to spread it around to more of the country. And we know that that's a key part of getting more buy-in and getting more forecaster experience in general, is just having WoFS be more available to more of the country outside of our typical testbed period in May and early June, when much of the severe weather is concentrated in the center of the country. So we'll be doing that through the SVC. That also allows us to demonstrate some ownership of the Weather Service in the process for selecting a domain. It'll be the SPC who chooses the domain for these 20 runs that we've designated for this winter. You can also expect to see an expanding use of the system for some fire weather related events. In fact, there's a controlled burn going on right now in Utah. You may have seen there was a WoFS run for this yesterday. And it's a multi-agency kind of a science experiment around a controlled burn taking place in Utah. So we have some new smoke-related products that Thomas Jones, one of our research scientists, put together. And so he's running for that exercise, also going to be running for the fire weather test bed, the inaugural year of that up at the Global Systems Laboratory later in November. And I have wanted since last year to grab a Santa Ana event. We didn't get one last year, so I'll be on the lookout for that as well. So you may see some fire weather runs. All of what I've said, kind of does beg the question, what about a transition to operations? Because we've seen these successes like the June 15th case that you saw here today. We've seen so many of those types of examples over the past several years. I can tell you we are working hard with our Weather Service partners at an administrative level to move WoFS towards operations. And we've actually been having high-level meetings with NSEP and with Weather Service leadership for probably a year and a half now. We have a draft transition plan that's about as robust as a transition plan can possibly be without actually going into effect. Where we've landed at this point in the conversation is that WoFS has a ton of support from the field and from leadership, but there is no path defined to get a cloud-based model into operations. It's not clear whether NSEP would run that or some new kind of structure within Weather Service would be created. Now, we went to running on the cloud not only to be innovative, but also sort of self-preservation, because it's very difficult to maintain a supercomputer, high-performance computing system in-house here at the lab. So moving to the cloud-based model has given us a lot of advantages, like the multi-domains that we demonstrated this year. But Weather Service leadership is working with us to define that path, how to get this to operations, what will that look like, and who will run it. In the meantime, continuing to push the envelope with other things like porting products into AWEBS 2 and hazard services. We want to completely automate our ability to launch a run. Right now, there's a little bit of manual work that takes place in the morning to get a run going. Once we get that fully automated, the downloading of everything that we need for initial and boundary conditions, then we should have the ability to do some non-diurnal types of things where we run for nighttime events and things that aren't nicely in our typical diurnal severe weather window. Continually working on new visualizations, especially for the fire weather aspect, and we want to do more with social vulnerability and incorporating a social vulnerability index with WoFS products, maybe identify particularly hazardous scenarios at long lead time. And again, that SPC project this cool season will help with demonstrating some NWS use of the system and choosing the domains. So that's a quick crash course in what's going on with WoFS, and I'll stop there.
Thanks, Patrick, and Pat's dinner as well. So where can you find more information about WoFS and roots/tales from the tested webinars? Do check out the WoFS website, the web viewer, where you can see all the WoFS products when it's running, plus archive data, and the WDTD's roots/tales, a YouTube playlist where you'll find all of our recordings since 2018. So with that, thank you all so much for sticking with us for this long-ish webinar. So that is a wrap for our first Roots webinar. Thank you so much to all of today's presenters. I really appreciate having the perspective from multiple WFOs and our EMs and researchers all in one webinar. Really makes for a well-rounded presentation, so I hope you all enjoyed it. And thank you all to our attendees for joining us today. We hope you will join us for another Roots webinar later this year. We will likely be discussing operationally relevant results from the Vortex USA research project. Hope to see you then.